So as I said, in this playlist, I am gonna focus on problems, examples, designing of machines. Rather than focusing on theories. So I will expect you to learn the theory first, then watch this video. As we know that problems help us to understand the topics in depth. Okay, so today I will solve 3 problems. As I said in my introductory video that in this playlist, in each video, I will be solving at most 5 problems. So our topic of discussion will be designing of DFA. So I will solve 3 such problems, and that will help you to understand the topics in depth. I'll start with basics and then we'll cover all the types gradually. So let's start. Okay, so this is my first question. So the first question is, design a DFA that accepts all the strings starting with W, where W equal to 0, 1, and the set of possible input symbols is 0 and 1. So as I said in my previous video or in the first part, that I'll follow some steps. So the first step is, step 1 is, we have to think of all the possible strings that satisfy this condition. So my set will be like, so the first element will be just 0, 1, then 0, 1, 0. This also satisfies this condition, then 0, 1, 1, and so on. So this is my first step. Next step is step 2. We have to design a DFA that accepts the smallest possible string, and in this case the smallest possible string is 0, 1. So let's do this. So this is my initial state. Then for input symbol 0, we have to make a transition from Q0 to Q1. Then for input symbol 1, we have to make a transition from Q1 to Q2. And as I said, this machine will accept this string. So this will be my final state. Okay. We know that in DFA we don't have any external memory, so we memorize sequences using these transitions. This is its use. So this is my step 2. Now step 3 is, so we know that DFA is a complete system. So what do you mean by complete system? Complete system means in each state we should have a transition for each possible input symbols. Means in Q0 we have transition for input symbol 0, but we don't have transition for input symbol 1. So you have to make that. Then in Q1 we have to make a transition for 0, and in Q2 we have to make transition for all the symbols, because we don't have any transition here. So let's do this. So step 3. So Q0, this is my initial state, we have a transition from Q0 to Q1. Now the constraint says that all the strings starting with W, where W equal to 0, 1. So let's say I have got a string like 1, then let's say multiple ones, then 0, then 1. So this string actually starts with 1, so this machine will not accept it. So how to implement this? So in DFA we have a concept of dead state. So how to implement dead state? So dead state, how this works is, so we have to make a separate state, let's say QD, and how this works is, so for transition 1, so when this string will be encountered in Q0, so first this 1 will be scanned and it will reach from Q0 to QD. Then for rest of the string it will just keep on looping over this state, and for all possible strings for the rest of the portion. So it will not able to reach from QD to Q1. Sorry, for Q2. This is my final state. So let me do this first. So from QD this will not be able to reach Q2. So this is my final state, and when the string will be exhausted, this will remain in this state. So as this is not the final state, so this string will not be accepted. This is how it works. Okay, so this initial state is complete. Now let's talk about this Q1. So you should have a transition for 0. So let's take an example. So we are in Q1, means we have already accepted 0 and we need 1. But if we get, let's say, multiple zeros here, then 1, so the condition doesn't remain same. Now this time this string is starting with 0, 0, not 0, 1. So obviously for any 0, for multiple zeros, it will reach this dead state. So just think about this. So if this machine encounters this string, so first this 0 will be scanned, it reaches this Q1, then for all the zeros from this one to this one, it will just, for first 0 it will reach QD, then it will just keep on looping over this dead state, and when the string will be exhausted, this will remain present in this dead state, and as this is not the final state, so this string will not be accepted. So this is how it works. And when it satisfies this starting condition, so it has accepted 0 1, then for the remaining portion, even if it gets any possible strings, I mean if let's say we have multiple zeros or multiple ones, we don't have to bother about this. So I mean this machine will accept all the strings, just it will check this portion, and this portion is satisfied in this case, so we don't have to bother about the rest portion, so we can make a self loop over here. So this is how it goes. This is the process, and we'll follow the same steps for rest of the problems. Okay, so the next question is, design a DFA that accepts all the strings ending with W where W equal to 0 1, and the set of symbols are 0 and 1. So first step is we have to think about the possible strings possible. So this set is 0 1, I mean this is the smallest possible string, then 0 0 1, I mean this pattern, just keep this pattern, next 1 0 1, and so on. And the next step is we have to design the machine such that this machine will accept the smallest possible string. So how can you do this? So this is my initial state, then we have to, I mean for input symbol 0 we have to make a transition from Q0 to Q1, then from Q1 to Q2, and as this machine will accept this string, so this is my final state. Okay, so here the condition is ending, I mean we have to check for the ending portion. So like the previous one, we can't assure that, I mean we can't assure beforehand that we can just reject the string if it starts with 1, like the previous one as we did. Because as long as the string is not exhausted, we can't we can't predict that what will happen in future. So if in Q0 we have a transition for 0, input symbol 0, but we don't have a transition for input symbol 1. So as you know, DFA is a complete system, so we have to make a transition for input symbol 1, and we can use a self loop over here, because just think about the examples. So this will end with 0 1, so this any number of symbols or any symbols can be present before that. So this is the condition. So just think about an example, let's say multiple ones, as I'm talking about here, as I have used a self loop over here. So we can if we have something like this and we have this 0 1 at the ending, so this string will be accepted because this portion is constant. So we can use self loop over here. Okay, now when we are in Q1, means we have accepted 0 and we need a 1 to satisfy this condition. So let's talk about the examples first. So we have, let's say, multiple ones for this self loop, then let's say we have accepted as 0 symbol for this transition. Then if we have multiple zeros, if we have like that, instead of 1, instead of 0 1, if we have 0 then multiple zeros and then 1, the condition is still satisfying, right? Because this portion is still present. So this means that we can have a self loop over here also. Now the main tricky portion is here, ending with W. So now we are in Q2, means our string is like this one, let's say multiple ones, then a 0, then let's say multiple zeros and 1. So this condition is already satisfied. So now if we get 0, an extra 0, means this pattern is, we have lost the pattern, but we have again started with the pattern. If we have another one over here, so this string will be accepted. So this means from Q2, if we have if we have input symbol 0 and we just pass from Q2 to Q1, so now we are in Q1, so the string will only be accepted if the next symbol is 1, as we have talked about this here in this example. And if we get 1, so as I said, 1 1 1 1, then 0 0 0 0, then 1, and if we have 1 here, means we have lost the entire pattern and we can't say like this, the before example. So we have to again start from the very beginning. We have to again start with checking all the combinations, and we have to again check this pattern also, 0 and 1. So now you can realize that this is how it will be, this is the actual solution for this problem. Okay, so the next problem is, Problem for today is design a DFA that accepts all the strings having W as a substring where W equal to 0, 1 and set of possible input symbols as 0 and 1. So we first talked about the starting condition, then ending condition, now the intermediate condition. And all the, these are the possible questions that come. Okay. So as I said, the first step is we have to check all the possible strings. So 0, 1, here the strings, possible strings is 0, 1. This is the smallest possible string. Then we can have 0, then 0, 1, then let's say 0. Or we can have 1, 0, 1, 0. Or we can have 0, 1, 0, and so on. So this is my step 1. Now the step 2 is, as I said, I have to design the DFA such that this machine will accept the smallest possible string. So my Q0 is the initial state. So from Q0, for input symbol 0, we have a transition from Q0 to Q1, then from Q1 to Q2. And as I said, this machine will accept this string. So Q2 will be my final state. Now, this 0, 1 can be present in the string anywhere. Okay, it can be present at the starting position or at the ending position or at the intermediate position, anywhere. So there is, the intensity of the restriction is much simpler. So before encountering 0, we can have, if we talk about examples. So as I said, this 0, 0, let's talk about this example, 0, 0, 1, 0. So this 0, 1 is present at an intermediate position. So before encountering 0, 1, we can have multiple zeros or multiple ones. So as I said, this is a complete system. So we have to make a transition for 1. So as I said, we can have multiple ones over here. So we just made a self loop. So we have multiple ones, and whenever we will encounter a 0, we can have ones. So we have exhausted this portion and we have reached this 0 from Q0 to Q1. So now in the string we are here, and in the machine we are here. So now after accepting the first 0, again we can have multiple zeros. So again we can have a self loop over here. Now as long as we are not getting 1, we can't assure, we can't predict like before, as I said. So okay, so after exhausting all these zeros till this portion, whenever we will get 1, so we'll make another transition from Q1 to Q2. And now like the first one, so after reaching Q2, it means we are in Q2, means we have exhausted this satisfying condition already. So now we can have anything over here. So we can have zeros multiple times, we can have ones multiple times, anything. And that is the reason we have just made a self loop. So this is how we can solve this problem. So now all the possible types are exhausted, and stay tuned. Bye bye.